All right, so these are our notes on predicting precipitation in precipitation reactions. So imagine that we were going to do a precipitation reaction. So basically, you're going to throw all of the ions that you want to react into a beaker of pure water. What we need to find out are the concentrations of the ions high enough to be able to find each other and to make a precipitate. So far we've been using our precipitation, our solubility rules to determine if a reaction would form a precipitate. Well, we can look a little deeper into that and determine if the molarities of each ion that's in the reaction is actually high enough for a precipitation to occur. All right, we would have to have Q would have to be greater than K in order for a precipitation to happen. So let's look at an example and we'll work through this. A person mixes 100 milliliters of 0.0016 molar calcium chloride and 50 milliliters of 0.0081 molar potassium sulfate. So it gives us the solubility product constant for calcium sulfate, and we want to know if calcium sulfate precipitate will be observed. Okay? So the first thing we're going to do is write our net ionic equation. Okay? So we got to write the actual reaction, the precipitation reaction that is taking place. So I'm going to just go ahead and write this out molecularly first. So we have calcium chloride and potassium sulfate, and that reacts and produces calcium sulfate and potassium chloride. And so I'm going to go ahead and write this out. So this is our precipitate that's forming. So we have calcium ions and chloride ions and potassium ions, sulfate ions, and we'll make the solid calcium sulfate and potassium ions and chloride ions. And we're going to cross out those spectator ions, which are potassium and chloride. So our overall precipitation reaction is calcium plus sulfate makes calcium sulfate solid. All right. So the next thing we're going to do is write the dissociation equation or the ionization of our solid precipitate. So we're going to start with the solid, CaSO4, and at equilibrium, we have calcium ions and sulfate ions. Okay. So our Q expression is going to be Q is equal to the concentration of the calcium times the concentration of the sulfate. We don't need to raise any powers here because there are no coefficients in the equation. Okay. So now we're going to calculate the molarity of the ions in the total solution. Okay. So we have 2 ions in the solution, so we need to find the molarity of our calcium ions, and we need to find the molarity of our sulfate ions. So there's the 2 ions that we need to find the molarity of so we can plug them into our Q expression. Okay, so to do that, we need to come back up here and look at our volume and our molarity. So for calcium, we have 100 milliliters, and it gives us the molarity. Remember that these are being added together, so the total volume is going to be 150 milliliters. Okay, so let's go back down here. We're going to multiply the initial volume of the calcium, which is I'm going to change this to liters, 0.1000 liters times the molarity of 0.0016, and that's moles per liter, so the liters cancel. But that's going to be divided by the total volume of the solution once both solutions are added together. So that total volume is 0.1500 liters. So we have this, it's the same number of moles, but now it's been, when you put the two solutions together, you now have a total of 150 milliliters or 0.1500 liters. So that gets us to a molarity of 0.0011 molar calcium ions. Now for sulfate, we have a molarity here of 0.0081, and that's in moles per liter. And then the volume is 0.05, I'm putting this in liters, 00 liters, so the liters cancel. Again, all together, 0.1500 liters. Okay. And the molarity of our sulfate ion is 0.0027 molar. Okay, so we're going to use those molarities to calculate Q, and then we'll just compare Q to K to see if Q is bigger or if Q is smaller, and that'll tell us if we will get a precipitate or not. Okay, so we're going to plug this in. Q is going to be equal to the concentration of our calcium ion, 0.0011, times the concentration of our sulfate ion, 0.0027. So Q is equal to 3.0 times 10 to the negative 6. Okay. Now we need to know what K is, and that's given to us up here at the top. Tells us that the solubility product constant for calcium sulfate is 2.4 times 10 to the negative 5th. Okay, so Q is, let me go back up here, 3.0 times 10 to the negative 6, and then, so that's Q, and then K is 2.4 times 10 to the negative 5th. Q is smaller than K, so that means that the reaction with Q is smaller than K, so it's going to proceed forward, which means more ions, greater solubility, which means there is no precipitate, okay? Because there'll be more ions, less solid, okay? So that would be no precipitation, right? So you're gonna compare Q to the KSP lookup value, and it is temperature dependent, so you do have to check. So if Q is greater than K, a precipitate will form. If Q is less than K, then you get no precipitate. If these are equal, it is fully saturated, or think of it as it is on the brink of precipitation. Okay?